Hey everyone, this is FixReef, and today we have another Apex DOS up for repair. This came in after a significant water damage, but the owner attempted to do basic cleanup and repair. They just ran into problems that they could no longer fix and asked me to see if I could fix it for them. You can't really see, let me zoom in this a little bit. You can't really see a whole lot of damage, but if I just tilt it like this, you can see that the board has been cleaned quite a bit. But other than that, I don't see a whole lot of problems here. So USB ports and all the other ports seem clean. I don't see any corrosion. All of this is just glue over on this side, so that's not a big deal. But let me get under the microscope and I'll show you the excess of the damage that this board originally had due to corrosion and how much was already cleaned up by the original owner. First of all, let's start from the power source. You can see that there was some soldering done on some of these pins. Some of this is fresh solder throughout, and it's done fairly well, but you can see that, for example, this buck converter over here has this orange hue to some of the pins. Let's see what else. More solder over on this side, and I'm not sure if this is actually, no, it seems to be solder. I would just add some solder here, just to be sure. Here is the voltage regulator. Once again, exposed copper, which means that at some point this was all corroded, and part of it was eaten away by salt and water and corrosion. Then there is this circuitry for the actual stepper motor driver. You can kind of see that, for example, this capacitor over here, I'm not sure if there is enough solder on here to actually conduct anything. And some of the pins also have been corroded, somewhat. Not significantly, but somewhat. Then we move on to the main CPU, main controller, and once again, power pins are the ones that have been at least partially corroded. So this is what I typically see. There is typically some corrosion or exposure to salt water, and then you plug it in, and quite a bit of power goes through those pins, and current combined with salt water corrode away the traces and corrode away the pins, and all of the power pins and ground pins start looking like this. So, and the same goes with this power capacitor. And we move on here, same exact problem with this and with this driver too. And basically mostly throughout. This side doesn't look too bad, but there's not much going on this side. But it looks like this whole thing was submerged in water, then pulled out of the water, plugged into power, and corrosion set in and took hold in all of these components. Alright, so now that we've seen the extent of the damage, what are we going to do about it? My basic concerns here would be, do we get enough power through the buck converter and the voltage regulator to run this circuitry? Did we have the CAN transceiver blown because things shorted and this is gone? Are the drivers, so there is one driver per stepper motor, so for each pump there is a separate driver, are those drivers bad? And last but not least, is the main controller dead? All of this is now a possibility. The board looks fairly clean, so I'm going to go ahead and plug it in with very low voltage, very low current, and see if anything heats up, if anything causes issues here. Okay, my bench power supply. Let's provide some power. Didn't go into the dead short, which is a good thing. It's actually consuming a little bit, so that's not big of a deal. Let me see if anything heats up right away. It's all good news. It means that something's alive here, something's working. But what exactly is wrong? Let's test some voltages. I have done repair like this already before, or I have shown repair like this before with these DOS modules. Let's see, it's just this one has quite a bit of work done to it, so it'll be curious to see what exactly went wrong. Let's test for some output voltages. 12 volts out of the buck converter, obviously, by the way, 24 volts at the power supply. 12 volts out of the buck converter. Voltage regulator, let's see if this is producing anything. 5 volts out of the voltage regulator, so we have all of our voltages done and working properly. That's excellent. So we have 12, we have 24, and we have 5. 5 coming out of here, so that's all good. Let's see. Do we have enough on the controller itself? Uh-oh, that's not good. Controller is going to work on this unit anyway. Controller works off of 5 volts. This is showing under 3 volts. That's not good. All right, let's test the drivers. Okay, I'm seeing slightly under 24 volts on this driver between the two pumps. These are the voltage pumps. These are not actual pumps. So 22 is good. And we have nothing on this. Also, some of you asked if I use some fancy techniques to find out problems, and I really don't. Once you work with enough of this, you know what to expect, what type of voltages, what type of resistance to expect across these components, and when you see an anomaly, you know there is a problem. All right, so what I propose we do now is we run this through a good ultrasonic cleaner, get rid of all of the mess that's on the board right now, get it to a nice clean state, then test again, see if sometimes ultrasonic cleaning takes care of some of the basic things that are hard to see on the surface with the naked eye. Okay, so the board is back from the ultrasonic cleaner. As you can see, it's in a much cleaner, better shape. Ultrasonic didn't get rid of the glue here, but that wasn't the purpose. I just wanted to clean up all of this other mess that was created here from its previous state, from the previous repair attempt, and also any kind of corrosion that might have been left on the board as well. The other side looks pretty good too. Okay, so a quick test. Let's see if voltages improve in any way after cleaning. I doubt it, but every once in a great while, I'm surprised by this. We have same 24 on the input, 12 at buck converter, 5 at the voltage regulator, and unfortunately only 3 at the main controller. Also, voltage here is still 22, so that's good, and the voltages here are still 0, so that's bad. Alright, so let's start by removing the main controller. If we remove the main controller and the voltages here are still at 3 volts, we know that the problem is with the capacitors. Otherwise, it's likely the main controller. It's easy enough to remove, so let's go ahead and do it. Alright, so let's add a little flux all the way around. If this was already worked on, I would imagine that the solder is already mixed with leaded solder, so it should actually come off pretty easily. It's already starting to melt. And it's lifting off. This side is good. Good. Also good. And the last one. All right, it's consuming a little bit less power now, less current, with the controller removed. So obviously something was using it. But then again, a little bit of consumption on a standby controller is something that you would expect. Anyway, let's see if we get our 5 volts back. Here's 5 volts coming out of the voltage regulator. Oh, how interesting. We don't get any voltages on this anymore. That's not what I would expect. So let's find out why we don't get any power. Look at this. So the power from the 5 volt voltage regulator is going all the way here. So this is the end of the trace. There is a via over here. There is going to be via coming out on the other side of this board. There is going to be a trace on the other side of the board that connects to this via, and then it comes out here and goes into this capacitor, and then eventually into the pin in the controller. But look closer at this via over here. I don't think that there is much copper left on this via to make a good contact. The copper is all gone from here. That was not me probing around. That is just the via completely gone. So we'll need to fix this, because I am very curious whether or not I am going to get decent voltage in here, and whether or not this was in fact the problem with the controller. All right, to fix this, this is what I'm proposing. This 5 volt power goes not only to the controller but also to the LEDs, and there are some other consumers of this, so we'll need to make it right. We'll need to make sure that it's fairly well restored. It looks like the copper is on that trace is very good. No issues with the copper. It's always good news. All right, so on the other side of the board, you can kind of see some of this rubbing alcohol came out, and these are the two areas, two spots where the two vias connect. So this is the input, and it goes here, and this is where on the other end it connects to the capacitor on the CPU. All right, so to repair this trace, because I do care about the way how all of this connects, I am going to attempt to run a jumper wire right through the via on the other side and connect it that way instead of running a jumper wire across this two. This would be a much cleaner solution if I can pull it off. But to do so, I'll need the wire to go through the via. So let's get under the microscope and see if we can fit it through. All right. Hopefully you can see this. And we're through. Excellent. Let solder this side, then the other side. We should be all set. And solder. And there it is. Nice and clean, and uses minimal space. Now jumper wire comes off. And I will seal this eventually. Just need to clean up this side a little bit better. As you can see, all of that flux immediately disappeared. Now flip it over. And here's our wire sticking out through the via. So we'll do the same. and a bit of solder. That's all we need. Cut off the excess wire, clean up. All right, and like nothing even happened here. Okay, with the via repaired, let's plug it in again and do measurements. Well, actually, before we even do so, how about some continuity? From here, looks like we got it. Good, good, good. Also good. All right, we got continuity now. So now let's have power and ensure that we have 5 volts coming out. And we have 5 volts now. Excellent. But now with the VA repaired, I am very curious if the original controller was actually working. Let's put it back in. I'll have to put some leaded solder on here anyway for replacement controller, and it's going to be very easy to swap them once that's all prepared, cleaned up and everything. So let's throw the original controller on, plug it back in again, see if the voltage improved at all. Okay, first off, put some leaded solder on here. See how nicely everything's flowing now that everything's clean, there is no corrosion on it anywhere. It just lays down so easily. All set. Let's test the original controller, why not? These controllers are very hard to come by anymore. So I would rather make sure that it's not working than to just throw it out. We aligned it best we could. Let's put it in. Should be nice and easy now that we have all of that leaded solder in there with much lower melting temperatures. Just like that. Nice and clean. Now, I am going to go ahead and test this before I actually do any kind of cleanup, because chances are very good that I may have to remove this because it's not working. All right, the first test is the usual test. Are we going to get 5 volts going into this controller? And are we going to have a short? Huh, look at this. The controller is actually working. It's blinking green, but I think it's actually working. Let's measure the voltages just because we can. and it's 5 volts. So the problem to the main controller was the via being completely gone. What do you know? Okay, in that case, let's test some voltages across these guys. 22, and nothing. This is still nothing, so the driver is likely still a problem. The other thing which is independent of the driver is the CAN transceiver. Do we have a good CAN transceiver? So I'm just going to go ahead and plug it into the apex, and let's see if we get some connectivity. Unlikely, but let's test. All right, so I'm not seeing any changes with the LEDs here, so that's never a good sign. All right, replacing the CAN transceiver is not going to be that big of a deal. All right, I connected to the Aqua bus, and it still would not connect. So the problem is not, or maybe not only, the CAN transceiver, but something else as well. But first, continuity. Continuity to the via. And continuity to the via. Now let's find the UART that they're using. RX and TX. So this is via coming from the CAN bus. Wrong. I am not getting a direct. Huh. Do we have another bad via? So this works. This one does not. Do we have another bad via? Let's take a look. So these are the two vias. Let me zoom in. Oh yeah, this via is bad. Let's take a closer look. This whole well is messed up. Might still be repairable without the wire. But on the flip side, let's just not mess with this. Let's repair it the proper way. Of course, this means that now I have to once again remove my controller out. Yeah, so these are the two vias, and you can see that this via is also quite bad. So while at it, I better check other vias that are of the question. Because some of this is leading to the controllers. So this is good. So it turns out many of these vias that are open vias that clearly had rust on them are actually bad. So we're going to have to clean up a lot of this. Okay, let's get to it. I don't trust any of these vias, so we'll need to have it all fixed up. Okay, so all of the vias that I had issues with have been repaired. There are at least 5 or 6 of them. One here, one here, one here, 2 over here. All looking nice and clean. Now we can put back the controller. Alright, the controller's in. Let's fix up some vias that shifted a little. Otherwise, everything looks very well connected. A bit more cleanup around the controller. Okay, now let's test connectivity again. Power first. The usual lights. Now Aquabus. And we have change in LED color. I think we finally got the connectivity. Let's see. Yay! It's connected. All right. So we solved the connectivity problem. The next question is, did we solve the problem of the drivers? So power once again. (22) and 22. I think we got everything fixed. Okay, so this board is likely all fixed. The big question at this point is, will it actually drive the motors? To test this, I have this unit that I use for testing primarily. This way, hopefully, it can be seen in the camera. Or I suppose I can do it this way. Now let's connect power. All right, obviously nothing is going to be lit up here because all of this is connected on the board. So let's attach the main controller. LEDs changed. Let's see if I can get it to spin like this. One and the other. One and the other. One, the other. Let's test through the controller. Okay, let's do some testing. Here's one on, and it's spinning. Here's the other one, and it's spinning. There is both, and they're both spinning. Well, I think we have another DOS fixed. Let's go over what happened here. My original thinking was likely the controller is dead, both drivers, or at least one of the drivers is dead, and the CAN transceiver. I replaced the CAN transceiver anyway, but it appears that actually the main controller and both of the drivers are okay. And the issue was primarily that all of the vias here were all rusted through. And the only way really to fix those vias is to, under the microscope, run very small jumper wires across and restore them that way. It's very hard to do this type of work without a microscope because you need that magnification. You literally cannot run a needle through a via like this. You have to have a very, very tiny wire that you can fish through and try to fix it. I am particularly happy about this repair in that there is no ugliness of the vias. repair, right? There is no ugliness of the jumper wires. It's basically just jumper wires going straight through the board and connecting to the traces on both sides, and the rest of it is history. So this worked out very well. I also repaired the connectors that were clearly partially soldered, and a few of the capacitors and resistors that clearly were not fully connected. And the board is working again. Well, this completes the repair. If you enjoyed this video, please like and subscribe. Leave a comment down below if you have any questions, and I will see you next time.